Thank you for tuning in to listen. Let me appreciate you sincerely. I would like to cover something pretty started. I had taught the topic commercial arithmetic, and in this session, I would like to review the same topic, but to be specific with a given subtopic therein called compound interest. Therefore, I'll be perusing the same subtopic, making clear a few things, and I believe you perceive the subtopic simpler and easier to handle. I'll clarify everything. I'll manipulate the formulae to at least calculate each element in the formulae. Therefore, let me start by simply defining what interest is. We all know that interest is the money charged due to money borrowed or money deposited. So if you deposit money in the bank, it will earn interest. So that money you withdraw, which is above the money you had deposited, is what you're calling interest. So interest can either be simple or compound, depending on the terms in the firm where you're investing. Again, money borrowed. When you borrow money, you return with interest, or you return with a little amount above what you had borrowed. So that given amount above what you had borrowed or what you had invested is what you call the interest. Therefore, interest can either be compound or simple. Let me give an example on the two, because I'd like us to understand what exactly happens in each type of interest. I'll be handling compound interest. This is where I'm saying, for example, Jane invested 5,000 shillings in a bank for 2, or let's say for 3 years. Find part A, the interest or the simple interest after the 3 years if the simple interest rate was 10% per annum. And part B of the same, find the compound interest if the compound interest rate is 10% per annum. 10% per annum. Solution to this question. We earlier on stated that simple interest is calculated with the formula principal times rate times time. Simple interest is calculated by principal times rate times time. Therefore, the principal is always money borrowed or the money deposited in a bank. So here, Jane deposited 5,000 at a rate of 10%. So percent means over 100 for 3 years. So at the end of the 3 years, our money had gained interest worth 1,500 1,500 shillings. So this is the interest Jen earned for depositing 5,000 in a bank which charged simple interest at the rate of 10% per annum for 3 years. It's part A. Now, let's go to part B. In the first case, where we are talking of simple interest, it is a case where the interest charged or earned on the principal depends strictly on the principal alone. But now, when we come to compounded interest, here, both the interests and the principal which had been deposited or borrowed, they are accumulated, and for the next period of interest, they earn interest together. Let me solve the part B stepwise before I give a general formula to help us understand more. Now, you find that in the first year, we have 5,000 deposited at the rate of 10% times that 1 year, and we get 500. Now you find for the second year now, the money in the bank is for the second year. The money in the bank, we have the 5,000, the initial principal, then 500 has been gained as interest. Therefore, she is already having 5,500, and they will both earn interest together for that second year. And you'll find that this one is 550. The interest for the second year is 550. Now, lastly, for the third year, now she had 500 and 550 interest has been gained. Therefore, find it's 5500 plus 550. This gives us 650. So, at the end of the second year, she was having 6,050 shillings in the bank. So now, cumulatively, it is this amount which is going to in the third year. So in the third year, we'll be having 650 by 10% times 1 year, the third year. So times 10 all over 100. This gives us 605. This gives us 605. Therefore, in this case now, you find now at the end of the third year now, she's having an amount. The total amount now is 650, and during the third year, 605 interest was gained. Therefore, when you add, you get 66. Therefore, this is the total amount she'll be having, because for the first year, interest was earned. Then the interest, together with the principal, they earn interest. Interest is gained. Again, the same, this interest, now plus again the principal which was there, it becomes this one. They earn again interest together. Therefore, all the money added now in our bank at the end of the third year shall be this one. So this will be the amount. So compound interest, the compound interest will be, now this total amount minus what she deposited initially, 5,000. And you find the interest which has been gained is 1,655 Kenya shillings. So, this is the amount which will have been earned for the 3 years. The interest earned. So, you realize that now Or instead of getting it by taking amount minus the principal, we can just add the interests gained in each year separately. 500 plus 550 plus 605, you get automatically the same amount. So you can just simply add the interests. So this is the amount gained under compound interest. But now, instead of following all this procedure, we can have a general formula. Actually say that generally, the amount A principal P is invested, deposited or borrowed on compound interest rates at rate R for n periods. Is given by so the amount after several periods of compound interest can be calculated by taking the principal into 1 plus the rate, which is a percentage, then raised to n. We can take for our case above, we had the 5,000 deposited, then 1 plus at a rate of 10% raised to n, where n will be the 3 years, the periods of compound interest. Therefore, n in this matter is 3. N is 3, the 3 years. R is the rate, 10%, and the P is the principal, 5,000 had been deposited. Therefore, now we can calculate this amount and see 5,000 into 1.1 raised to 3. Therefore, we can have 1.1 raised to 3 times 5,000. And this gives us 66.55. 66.55 shillings. So this is the amount which accumulates when you compute using this formula. And if it's the accumulated amount, then we can subtract from get interest. So compound interest can be determined using this formula. So that's how it is supposed to be done, using this formula. I would like now to give several examples which are going to manipulate this formula and make us understand deeper the concept on compound interest. So follow me as I give us second example. Which amount is given by principal into 1 plus rate raised to n. N is the number or the seasons of simple interest. So let me give a question here which says after investing, another example, after investing 36,000 Kenya shillings, an amount of 37,454 was realized at the end of 2 years. Was realized at the end of 2 years. Calculate the compound interest rate. Calculate the compound interest rate that was offered by the institution. That was offered. That was offered. Now, we all remember the formula that amount is given by principal into 1 plus rate raised to n. Therefore, we can see the amount is already given as 37,454.40, and the principal which had been entered is 36,000. Then we can see that it is after 2 years, which will be our n in this case, 2 years. Therefore, what we're calculating is the rate of compound interest. Therefore, we can say amount, which is already here, that's 7,454.40, is equal to the principal, and the principal in this case is 36,000 Kenya shillings into 1 plus a rate now which we don't know, but we're sure it's a percentage. Then this one we raise to power 2 because 2 is the n, and n here is the number of the seasons for compound interest. Therefore, now because the unknown is here, then we can now start evaluating this one, and I can start by first of all dividing through by 36,000. Therefore, when we take that 7,454.4 divided by 36,000, we getting 1.0404 is equal to 1 plus a rate of 100, and this one is raised to 2, or squared in other language. Therefore, now because we have a square here, to do away with the square, we can take out square root both sides. So when we carry out square root both sides, then this one, the square root will be 1.02 is equal to, when we take square root here, the term remains now the way it is without the square root sign. Because when we are taking the square root of a power, we just half it, and 2 divided by 2 becomes 1. So this raised to 1 remains itself. So now, because we want to remain the unknown, we can transfer the constant to this side, and 1.02 minus 1 becomes 0.02 is equal to r all over 100. Therefore, to remain now with r on one side, we multiply both sides with 100, and multiplied with 100, 0.02 becomes 2. Therefore, we can say rate is 2% per annum or per year. So that's the rate for compounded interest in this institution. So let me submit another example, possibly which will be asking now a different thing, still dwelling on the same formula, still manipulating one formula, manipulating the same formula in different ways, trying to get another. Yes. Banda deposited 65,000. Banda deposited 65,000. Banda is a human being. So Banda deposited 65,000 in a bank that offered compound interest, in a bank that offered compound interest, a bank that offered compound interest at the rate of 5% per annum. At the rate of 5% per annum. Per annum means yearly or per year. Per annum. Yes, per annum. How long would it take for the money? How long would it take for the money to accumulate an interest of where is this one? 71,662 shillings. 71,662.50. How much will it take for the money to accumulate an interest of? This is a bit tricky. It's good to realize that now, in this case, you've just been given the compound interest as, and the n is not given. Then we are told the deposited amount is 65,000 Kenya shillings. Rate is 5% per annum. So in this case, it's good. It's good we evaluate a question well, because if Banda is depositing this that rate of 5%, how long would it take, and it's to give us this interest? Therefore, if this is the interest, we calculate the amount. So the amount can be the money which had been deposited, 65,000, plus the interest generated, 662.50. So the amount at the end of those years will be 65,000 plus 71,662.5. This is 136,662. Really? 65,000? Yeah. This will be now the amount at the bank. If this is the interest accumulated, deposited this, then this will be the amount at the bank. Therefore, now we can go to the formula and say amount, which is 136,662.5, is given by the principal, 65,000, into 1 plus a rate of 5% over raised to n now, which is the number of interest periods, and we don't know. It's what we're calculating now in this case. Therefore, we can first of all divide by 500 through, so that we may remain with that term with the non. So this remains 2.1025 is equal to 1. Okay, we can add it directly. This is a 0.05. So 1.05 raised to a given power n. Now, at that point now, we go back to, we have an unknown here, which is an index in this case. Therefore, some of the laws of indices and logarithms is that when we have the logarithm of a raised to an index n is equal than the logarithm of a. So on this note, then we can employ logarithms here. Can employ logarithm log of 2.1025 is equal to the log of 1.05 raised to n. Therefore, applying now this law of logarithms, you can bring n here, the unknown. So the logarithm 2.1025 is equal to n, the logarithm of 1.05. That way. So with this now, then we can divide through by the log of 1.05 to remain with n on one side. So n will be log of 2.1025 of 1.05. So the log divided by the log 1.05 gives us 15.2, which is to accumulate this amount, it will be roughly 15 and a quarter years. So when we use this symbol, we mean it's approximately 15, because 0.25 is a quarter and this 2.3, then we can say that it's around 15 and a quarter years will be taken for this amount to be of interest to be accumulated in the bank. Let me check whether we can get a question which will be asking now the principal deposited. The principal deposited. Excuse me. So we given yes. A question is here now of the nature. Question of the nature. We are told a man, certain man, wants to accumulate 400,000 in shillings in 5 years. How much money must he invest now? How much money must he invest now? Must he invest now at 10% per annum, at the rate of 10% per annum compound interest? How much must he invest now at the given rate? How much must he invest now? Solution. We can again assemble the question and see what has been given, what is being asked. How much must he invest now? Principle is not known, but we given the amount. He wants to accumulate 400,000. Then again, we can see that n, it will be after 5 years, and we see again the rate is 10% per annum. Therefore, we can say amount 400,000 is given by the principal, which we don't know in this case, into 1 plus a rate of 10% raised to 5 years. Raised to n 5 years. Therefore, now we can have 400,000 is equal to P into 1.1 raised to power 5. So 1.1 raised to power 5 can divide it through so that we remain with P here. We have 400,000 all over 1.1 raised to 5. So P will be calculated using the calculator. 400,000 divided by 1.1 raised to power 5. Therefore, this will be 248, 368 dot 53. Therefore, the amount in shillings this man should invest now, so that after 5 years you'll be having 400,000, and the rate for compound interest is 10%, is this amount, 248,368.50 or 53, that is. So that's the amount is supposed, the money is supposed to deposit at the moment. So that after 5 years you'll have that amount. So far so good. So far so good. I'd like to give a question now, talking about compound interest, compounded semi-annually, and compound interest, compounded quarterly or quarter a year. So remember, this is a formula. The formula will not be altered by anything we're going to discuss here. Variations not, and not with a lot of concern. Record this not with a lot of concern that when interest is compounded semi-annually, or it's also called half yearly, the number of interest periods, the n, in other words, is determined by multiplying the number of years by 2. So if I tell you that compound interest is calculated semi-annually or half yearly, and I tell you for 4 years, then because 4 years will be having 2 semis each, then the total number of periods of compound interest, if we have 4 years and compound interest is calculated semi-annually or half year, it means for every year then there are 2 seasons for compound interest, meaning that now the total seasons for compound interest will be multiplied by 2. If compounded quarterly, the number of years are multiplied by 4. So if, again, compound interest is done quarterly, then each year will be having 4 seasons for compound interest. Meaning if there are 3 years and compound interest is quarterly, then the seasons for compound interest will be 3 by 4 in each year, 12 seasons. On the other hand, the rate of interest is divided into or divided by 2 and 4 for semi-annual and quarterly compound interest. Respectively. So, if compound interests, the rate is 12% per annum, compounded semi-annually. If for per annum it's 12%, then semi-annually it will be the half, definitely. So as we multiply the seasons or the periods for compound interest by 2 or 4 depending on the question, then contrarily we divide the rate of interest, because if per year it's a given rate, then in a quarter a year it will be a quarter that rate, because it's not ended. Let me climax this with an example. Let me give an example on this. If time allows us, I will give you. Compounded quarterly. Let me search a good example. Want to get a relevant example for this. Okay. Yeah, here we can't lack one. An example for that. Okay, we are told 200,000 is deposited. 200,000 is deposited at the rate of 6% per annum compound interest. If the interest is compounded half-yearly, find the amount after 2 years. Find the amount after two years. Find the amount after 2 years. Find the amount after 2 years. Here, the principal is not changing. It's 200,000 being deposited. 200,000 being deposited. Now we can check what will change here. So the rate is 6% per annum compound interest. If the interest is compounded half yearly, so per year or per annum it's 6%, meaning the rate now compounded semi-annually or half yearly, it becomes 3%. And here, if interest is compounded half yearly and it's for 2 years, we know that each of the 2 years will be having 2 halves, and therefore now the periods for compound interest will be 2 for the first year, 2 for the next year. So meaning the N will be 2 years times 2 halves in each, or times 2 seasons of compound interest in each case. So 4 will be the N in this case. Therefore now we can say now the amount after that time will be given by principal, money deposited, borrowed, to 1 plus a rate of 3% raised to 4. Raised to 4. Raised to 4. So this will be 200,000 into 1.03 power 4. This will be 200,000 in 1.03 raised to 3. And this will be 218,545.40 shillings. So the amount accumulated after 2 years will be 218,545.40 Kenya shillings. So that's it. That's how it to. I'd like to give the last example because I have some minutes remaining with us. Even though our lesson is ending, we can add something now. Can consume a few minutes for your break. We are told that Dennis deposited. Let me write it. It's a question involving Dennis. He deposited something in a bank. Deposited 320,000. Dennis deposited 320,000 at the rate of 12% per annum. At the rate of 20% per annum compound interest. Then we told if the interest is calculated a quarter yearly, if the interest is compounded or is calculated quarter yearly, find the amount. Find the amount after 3 years. Find the amount after 3 years. After 3 years. Find the amount after 3 years. Again, solution for this. Solution for this. We can see that the principal in this case is 320,000 Kenya shillings. Then here now we thought that the rate is 20% compound interest per annum and it's compounded quarter yearly. Therefore, if per year it's 20%, then in a quarter year we will divide this by 4 and the rate will be 5% now. Then now N, the number of interest period, interest after 3 years. So 3 years, and each interest is calculated after a quarter a year. So in a year we have 4 quarters, meaning that now the total number of interest periods will be 12 for the 3 years, each year having 4 quarters. Therefore now we can employ our formula. It says that amount is given by principal into 1 plus rate of 100 or percent raised to n, meaning 320. 1 plus a rate of 5% or raised to 12, raised to power 12, raised to power 12. Therefore, in this case, we shall have 320,000 into 1 plus 0.05 becomes 1.05 raised to power 12, raised to power 12. So this becomes 320 into 1.05, then this is raised to power 12. So this gives us 574,674 Kenya shillings. So this is the amount which will have accumulated within the 3 years, compound interest being calculated quarter yearly. So that's how this question ought to be approached. I wanted to mention something on appreciation and depreciation because they employ almost the same concept. The formula is just the same, because if we have let's say a given article, we have a piece of land bought at a given value, then with time the land appreciates or the land increases in value. Find that the land is selling at a higher price than it was bought, and in such a case where a commodity increases in value compared to how it was bought, we say that it has undergone appreciation. On the other side, we got materials, commodities, articles like cars, which when they are bought with the time, they experience wear and tear, and you find that they are increasing in value. Such commodities which decrease in value with reference to the original value, they are said to have undergone depreciation. Now, we say that for appreciation, the new value of a commodity is given by the original value, principal, into 1 plus rate, which is a percentage, raised to n. Therefore, a commodity appreciating its value after a given time, n years, at a given rate, then if the original was P, the new value is given by V is equals to original into 1 plus just the compound interest formula, only that instead of amount now, we are using value to mean the new value. For depreciation, when a commodity now is decreasing in value, its new value becomes principal into 1 minus rate all over 100 raised to power n. Now, where it is depreciation, we got 1 less the rate of 100, then raised to n. Therefore, this is the difference. Negative there for the decreasing in value commodity. For the increasing one, the formula is just as above. Let me give an example. For each that we may now finish. We thought that the value of a house, okay, we are told that Mercy bought a piece of land Matthew bought a piece of land. Matthew bought a piece of land at 80,000 shillings. 80,000 shillings. Then we told that it appreciated at the rate of 10% per annum. It appreciated at the rate of 10% per annum. Find its value after 6 years. Find its value after 6 years. Find its value after 6 years. Solution. This is now a land or land which was bought at 80. So the original price of this land, we can call it the principal, 80,000. Then we now told that its value is appreciating at a rate of 10% per annum, and we are told that to get the value it you have after 6 years, meaning that n will be 6 years now. 6 years. Therefore, the value, new value, is given by principal into 1 plus rate, because it's a percentage we rate over 100. Therefore, we shall have 80,000 into 1 plus a rate of 10%, then everything raised to 6, which is n. So this will be 80,000 into 10 over 100 is 0.1 plus 1, 1.1 raised to 6. So this becomes 80,000 into 1.1 raised to power 6. So this becomes 141,724.90 or 90 cents. So this is the amount for the land. So the land will be this expensive because it is appreciating in value, the rate of 10% per annum. So we use the compounded interest formula. So in case you have a commodity which is decreasing, this is how we approach it. Let me just give one to finish up the lesson. Just one example. One by finish. A dining table costs, just call it a table, costs 40,000 shillings. Its value depreciates. Its value depreciates at the rate of 2% per annum. Calculate the value after 3 years. Calculate its value after 3 years. After 3 years. Solution very fast. So here, which is losing value with the time, a commodity which is losing value with the time. It's a table costing 40,000. So we can have this as the principal, 40,000. Then it's losing at a rate of 2% per year, and we need the value after 3 years. So n will be 3, the period at which the table has depreciated in value. Therefore, we're saying the new value when a commodity is depreciating is given by principal into 1 minus, now instead of a plus, minus the rate all over 100 raised to n. So this shall be 40,000 into 1 plus, no, minus, sorry, dictated by the compound interest formula. So in this case, it's a minus then 2%, so 2 all over 100 raised to 3 or cubed. So this becomes 40,000 into 1 minus 0.02. We get 0.98. Then this is raised to 3 now, or cubed. So it should be 40,000 times we are having 647.70 shillings. So the new value for this table will be reduced to 37,640.70. So this should be the new value for the table. So that's how compound interest, appreciation and depreciation are related in general. Thank you very much for choosing my channel. Greetings from Boniface Katumuta. So thanks a lot, and God keep you safe. God bless you. Shalom.